Hello Internet, my name is Quinn and this is Blondihacks. If you watched my video on making copper soft jaws, you know that my mill went boom in the middle of that project. So this is the promised sequel that goes through what happened and the repair. I have to say up front, I did not catch the actual explosion on film, I'm afraid. So if you clicked here for that, you're going to need to just go back to watching videos of trucks hitting low bridges. No judgment, I love those. But I did catch something amazing on film that you are not going to want to miss. So let's go. So there I am milling my own business and working on my copper soft jaws here, and kaboom. Yeah, there was a huge flash of light and a loud pop from somewhere in the vicinity of the electrical box, and it blew the breaker in my shop, and the mill was dead, and now it's doing this. So powering it up, the spindle won't run, the display does light up, but nothing else happens. Now I have no idea what's wrong, but pretty clearly we need to get to the electrical box. So step one is to remove the coil lock here, which is in the way of getting access to the electrical box. So we take the handle off, and then the lock itself simply unscrews. And now we can go in there with an Allen wrench and get those screws out of the front panel. And here we get our first look at the internals, and it looks pretty straightforward. So this here is the contactor. Now that was my first suspect for what would possibly be wrong, because contactors do have a tendency to fail. So I figured, okay, I'll try and get this guy out and take a look at it. And I thought it was bolted in from the bottom, and I got the screws loose and then realized actually there's a little teeny piece of DIN rail in there that this guy is sitting on. So I didn't actually need to loosen that guy. So my first thought was to test the coil on the contactor, because this is an easy test that you can do. And you can see here on the multimeter that we've got 356 ohms on the activation coil, which according to the spec sheet is normal for this contactor. So the coil appears to be fine. It's a common failure mode for these. So at this point I stopped and went and talked to Precision Matthews, their technical support, and they said that, oh yeah, if this type of thing happens, it's almost certainly the driver board, the circuit board in there that drives the motor. So Matt sent out this kit, which includes a new circuit board and a new display and a new potentiometer. And there we get our first look at the circuit board. It looks pretty nice. You can see how it's all epoxy potted, which is quite nice. That makes it very resilient to vibrations. The way this electrical box is set up is quite nice. The entire circuit board unit is actually the back panel of the electrical box. So we just have to remove these cap screws back here. There's 4 of those. And then we can pull the circuit board away from the back. And you can see that I'm kind of working around the locks on the column there, because I'm trying very hard not to move anything on the mill. I don't want to upset the setup here. I want to be able to continue this machining operation once I get this repair done. And yeah, there's some wiring that's keeping me from pulling this guy away from the box. So I need to clip these zip ties. And here's a pro tip: if you clip a zip tie through the kind of the buckle part of the zip tie, you won't risk nicking any of the wires. And now we get our first look at that circuit board, and all the wiring is attached with a nice set of simple connectors, and everything is keyed. So there's really only one way that it can all go back together, but just in case, it's good to film or photograph this type of thing, so you make sure you get all those harnesses back where they belong. It's looking good. Okay, so here's the old board on the right and the new one on the left. So the first thing I check is the capacitors, just to see if they're puffy. Electrolytic capacitors, when they go, will get puffy, but they actually seem okay. I was a bit surprised. I was expecting to see some sort of significant damage here. I've seen a lot of similar boards like this fail in things like pinball machines and other high voltage equipment, and they never go quietly into that good night. So honestly, this board looks okay to me, but it's possible, you know, there is some discoloration around some of these parts, but it could just be the black potting epoxy, so it's hard to say. But since I have the new circuit board, let's put the new one in and see if it solves our problem. I mean, generally speaking, the power electronics are the weak link in systems like this, so I certainly expect this to be the problem, even if there aren't any signs of it having failed. So I just put a couple of screws back into that front panel, just in case this isn't the problem. I don't want to fully reassemble everything. Okay, let's give it a test. Power it up, and same symptom. The display lights up, but the motor won't run. So that's kind of disappointing. And yeah, fiddling with the potentiometer, nope, nothing. It's dead. Okay, so now what? Well, the kit that I got from Precision Matthews did come with a new potentiometer, so I guess it's worth trying to replace that. So I pulled this knob off. This guy was really on there. And I would learn later that's because I removed it incorrectly, but we'll get to that on reassembly. So this is a standard panel mount potentiometer. There's a little nut holding it on the front, and there's a jam nut on the back. And now that potentiometer pulls right out. And you can see there's a little hole in the front panel there, and that guy is a key, and there's a little nubbin on the side of the potentiometer there, and that's what keeps the body from rotating when you turn the knob. So now this is a bit odd. The potentiometer that I have in my mill is a 4.7K pot. You can see on the back here that it's 4K7. The K is the decimal point placeholder. So this is a 4.7 kilo ohm potentiometer, plus or minus 5% tolerance. But the new potentiometer is a different value. The new one is a 10K potentiometer. So that's a little strange. That's a pretty substantial difference. So either there's just a very large tolerance range on this potentiometer, or they've changed the design of the circuit board in some way, and the new circuit board requires this new potentiometer. So we'll swap it in. The potentiometer just plugs into the circuit board. So I get the contactor out of the way here again. And back to my favorite shop tool, the forceps. There's links to forceps down in the description if you want to buy a set of these yourself. As I often say, surgeons have the best shop tools you'll ever find. And I go to install it, and oh, look at that. Yeah, the anti-twisting key that I talked about is different on this potentiometer. So this guy will not fit in my front panel. So that's a little weird, but before I start cutting new holes to make this guy fit, let's see if it actually fixes the problem. So I temporarily hang that front panel, and I power it up, and no good. So it is not just the potentiometer that was broken. Now conveniently there is a schematic on the side of the box, and oh, see, here's the problem. I've got a potentiometer in there, and it's looking for a poet-nanometer, a device electrons to modulate, not dilly nor dally nor inundate, control the speed with any old feed, those electrons it shall consummate. So now I just started testing things to see if I can find anything broken. So next I checked the forward and reverse switch, and I've got a glove on here because I wasn't sure if it was high or low voltage, and it is low voltage. You can see on the meter there that it gives me plus 5 volts in one direction and negative 5 in the other. So that guy is just talking to the circuit board. It's not switching actual mains current. So the next thing I checked is the output on the contactor to see if the 120 volts is getting through. So I powered it up and tested that, and you can see 120 volts on the meter there. And here's a tip for working around high voltage like this. Do everything with one hand and keep the other hand behind your back, because then if you do get shocked, there's no chance of the current going through your heart, because that's what's actually going to kill you. It actually only takes a couple of 100 milliamps to kill you, but it takes a fairly high voltage to get that current through all of your meaty bits and through to your heart. But regardless, the arm trick will minimize the risk to you. So at this point, we'd run out of minor things that it could be, so it kind of was starting to look like it had to be the actual motor that had blown. That seemed pretty unlikely considering all the other weaker links that are upstream of it in the system. So I talked to Precision Matthews again, and they sent me this care package. Now, Precision Matthews is located in Pennsylvania, and you can see that this box came from their warehouse in the region of Pennsylvania. Yeah, it looks like we've got a new display and a new circuit board. So yeah, it looks like this is a full new electrical system for my mill. And here's the pièce de résistance, the thing that we're after. Is a beautiful new 1 horsepower brushless DC motor. So back into the electrical box we go. And since we've got all new parts, there's really no reason not to just shotgun this whole thing and eliminate any variables, because who knows, with all these other attempted repairs, if there's some part of the system that's causing other parts to go bad, you know, we could be just ruining parts as we go along. So since we have a whole new set of parts, we'll put a whole new set of parts in. And just to keep things interesting, this kit came with a third completely different type and spec of potentiometer. So I really don't know what's going on with the potentiometers. That's 3 kits, 3 different pots, none of which are compatible, none of which have the same rating or the same mounting system. They're really digging through the parts bins over there in China, I guess, for these potentiometers. It's very strange. And it came with a new display as well, so we'll swap this guy out. The nice thing is that all these parts are actually very modular and very easy to replace. And now we get to the motor itself, and it's mounted to this bracket that's got 4 cap screws holding it in place, which are definitely Loctited, judging by the way they're cracking loose. And unfortunately, these cap screws are actually held captive by the frame of the motor. So I'm having to work them all loose in a circle pattern and ease the motor up gradually. And at this point you might be wondering, why didn't I just remove those great big cap screws that are clearly used for belt tensioning and pull the whole unit off? Yeah, well, where were you with that advice when I was doing this repair 2 weeks ago? Anyway, it was around here that I realized I'm going to have to loosen this belt to get the motor out, so clearly the order of operations part of my brain called in sick this day. But with enough fiddling, out comes the motor. So now we need to deal with that electrical connection, and it goes down into the head casting. So I'm not sure how that's going to come out of there, but you can see it comes out into the electrical box here. So we pull the wires off of the circuit board, and this large connector is not going to go through that hole in the electrical box. So luckily this guy just unscrews. And of course I took a picture of those wires so I'd know how they go back in. And my idea here was to tie a string around this harness and then tape it off so it doesn't get snagged. And then pull the old harness out, and then that's going to draw the string through, and then I can use the string to pull the new harness back in. And this seemed like a good idea right up until the point where it became clear that that smaller connector that is not removable doesn't go through this grommet on the electrical box. So I was faced with maybe having to do surgery on that harness to extract it. But before I do that, I want to make sure that this set of parts is actually going to fix the problem. So I rigged it up temporarily on the bench just to see if the motor would run. And it does. That's very exciting. That's the first time I've seen a motor run on this mill in multiple weeks. So that's great news. It seems like this repair is worthwhile. So then I took the plunge and I just cut the old connector off of the broken motor and pulled it out. And wait a minute, you might have noticed something there. In my zeal to extract that old harness, I actually cut the string off by mistake, and I pulled the old harness out without the string on it. And this is a move that I would come to deeply regret later. But past me doesn't know that yet, so past me is now tackling transferring the drive pulley to the new motor. And I assumed it was pressed on there, so I got my puller on there, and it was pulling pretty hard. So I started to get suspicious, and yeah, sure enough, there's a set screw in it. So I'm really winning here on this repair. Now let me pause here and tell you a little story. On a previous video, in the comments, the subject of set screws came up, and one of my commenters mentioned that, Monarch used to do this crazy thing where they would put multiple set screws in the same hole as kind of like a jam nut situation, but with set screws. And then someone else commented, yeah, Bridgeport likes to do that too. And I remember thinking, wow, that's crazy. Well, that would never happen to a machine like this, but I'll keep that in mind if I ever work on a Bridgeport or a Monarch. So I got the puller going again, and it was still pulling really hard, but I thought, well, I got the set screw out. Yeah, guess what? Double set screws. So, I chowdered up that shaft pretty badly, but it doesn't matter because this is the old busted motor anyway. Next I needed to transfer that key to the new shaft, but that key was really in there, so I had to get the vice grips out and do some unfamily-friendly things to get it out of there. And so of course it was chowdered up, and I had to take it to the emery paper and fix it up. And yeah, this key is pretty shockingly poorly made. It's clearly just some square key stock that someone has kind of taken a swipe at with a belt sander, and it really wasn't a very good fit for the keyway. So I spent some time and corrected the shape of it so that it will actually go nicely into the keyway. And now we can transfer the pulley over to the new motor, and yeah, it doesn't fit because of course it doesn't. The inside bore on that pulley is not very good. So you've probably seen this trick before. You cut a slit in a bar and you put some emery cloth in an S shape in it, and you've got yourself a cylinder hone. So some quality time with that guy, and now it's a good fit on there, so we can slide that guy right on. And it's important to get the depth on this just right. I measured the depth on the old pulley so that I can match it, because the depth here is setting the alignment on the ribbed belt on the spindle. And in go both set screws. Yeah, both. So now I just needed to transfer this mounting frame from the old motor to the new, and that goes on there real nice. And I can just put in the new screws, no problem, looking good. Wait a minute. Yeah, the mounting holes in this bracket didn't line up with the new motor. And I don't mean they were a little off, they were a lot off. Now, not so far off that I could drill new holes in this bracket, but I did have to open up these holes about 50 thou to get them to kind of mostly line up to the point where I could get the bolts in. That's pretty surprising that there was this much variation. The bolt pattern in the motors should be the same. I really don't know what happened here. But I put the hardware back in and I put some Loctite on there and away we go. And this is the point where I realized I had ruined my own clever trick with the string. So I busted out another old mechanics trick, which is that zip ties make quite a good fish tape for short distances. So I thought, well, I can just fish a zip tie down through the head casting, and we'll just leave that there for later with the forceps holding it in place, and go ahead and get our motor reinstalled. And now I can tie a string to that zip tie and pull the zip tie through. And this will give me my fish cord for the head casting. And so now I need to get it laterally from the inside the head casting over into the electrical box. So I figured I could fish another zip tie in through the electrical box to do that. So fishing around, got my hand in on the other side, and yeah, this was not possible. It turns out the head casting is double walled, and the hole where the wiring feeds through the side is actually offset in the two elements of the double wall, and there's a 90-degree bend in it. So I have no idea how they fed that wiring through in the factory. They must do it from the back with the head off of the machine, because it seems to not be possible with the head on the machine. Once it was clear that recreating that factory routing was going to be impossible, I just decided to make a new hole in the electrical box and route it myself. And interestingly, while I was doing that, I found a loose screw from the ground bus bar in that electrical box. I wonder if that shorted something out and caused this whole problem. But anyway, with the pilot hole drilled, now I busted out one of my favorite tools, the step bit. If you need to make large holes in sheet metal, these things are awesome. They do require a fair amount of torque, so you can see I've upgraded to the corded DeWalt drill here. That first drill you saw, the red one, is actually an original Black & Decker 12-volt cordless drill. I think it's the last remaining 12-volt NiCad cordless tool on the planet. But the thing just won't die, and I can't justify upgrading to one of those nice new lithium 60-volt whatever tools until this one dies. And for basic woodworking and kind of DIY stuff, it works great. It does not have, however, the oomph for something like a step bit or drilling holes in steel. So for that, I keep the DeWalt around, and that corded DeWalt will break your wrist. That thing is a beast, and I've never found anything that'll stall it. And then I thoroughly vacuumed out any debris that was in there. I didn't want to risk any metal chips getting into the electricals in there. And so now I needed a grommet to protect the electrical from that hole that I made in the sheet metal. So I've got a solid grommet here that I've cut a little X in to make sure that no chips can get in there. So you can see how that's going to work. And I feed that over the heavy outer sheath. And then I feed that whole business up into the electrical box, and I seat that grommet in there nice and snug. And the rule of thumb with grommets is that if it's not almost impossible to get into the hole, then you're using one that's too small. And so now I can reinstall the large electrical connector on the motor, and my friend the forceps are pressed into service once again to reconnect those guys. Fun fact, forceps is an invariant noun, or sometimes called a defective noun, which means that it is its own plural. Now I had the question of which of my 3 potentiometers that I now have should I use here. The one that came with the newest kit is the one that looks like they ripped it out of an 80s 8-track player, and so it didn't have any markings on it, so I tested it. You can measure the maximum value of a potentiometer by measuring the outside terminals, and this new mystery one was 1.7 kiloohms, so 3 different potentiometers, 3 different ratings with a 10K swing between them. That's extremely strange for electronics. I've never seen a potentiometer spec that variable before. Variable? Huh? Yeah. Blondihacks. The puns are free. In any case, I decided to install my original potentiometer because that's the one that actually fits in the panel. So power it up, and it spins. It runs. Standard Imperial Celebration Fist. And there may have also been some floor-based celebrations. So then I went to reinstall the knob and realized that I had removed it incorrectly. That brass friction fit business is actually a collet. So you can pop the back cap off of that guy and slide it on there and just tighten the little nut. So that's actually a really nice high quality knob. Yeah, go figure. So everything seems good, except there's something fishy there. The highest speed on the mill is showing as about 320 RPM. What's going on here? Something is definitely not right. So I thought, okay, maybe I do have to use the disco potentiometer. So I swapped that one in, and hey, who's got 2 thumbs and is the shortest path to ground? This gal. Let's pause here and note that, yes, I did in fact electrocute myself. I'm not entirely sure how it happened because my finger on the back of the panel there wasn't near anything high voltage, but the video doesn't lie. so I put a heavy glove on for the remainder of these tests with the panel open. So after gathering myself up and changing my shorts, I gave it another test, but it was still showing an RPM that was much too low. So at this point I wondered, is the RPM display wrong, or is the spindle actually running that slow? So I got out the laser tack and measured it, and sure enough, at maximum speed it is running at 1290 RPM, which is what it should be. So interestingly, the RPM display on the mill is showing exactly 1/4 of what the RPM actually is. So that can't be a coincidence. So that makes me think there's something up with the Spindle Rpm sensor. And that sensor should be accessible from inside the front of the head casting here. So I just take off the fine feed Coil knob, and then I just pull this panel off. Here's the sensor that's actually in there. It's an opto sensor, much like you'll find on pinball machines, and there's a disc around the spindle that spins between those two legs there. And there's a light that's shining through, and it's looking for holes that are in that ring. So every 4 holes is 1 RPM. So that's an interesting coincidence, because that makes me think it's only reading one of the 4 holes, and that's why it's reading 1/4 RPM. But while it does have adjustments here for alignment, I tried correcting the alignment. It was a little bit crooked, didn't help. So one of the kits I got from Precision Matthews did have a replacement for that sensor. So I thought, well, I'll try swapping that in. Still the same problem. So I had one last thing to try, and that's swapping out the actual RPM display itself, because I now have 3 of those with all of these kits that I got. So the next one I tried, well, this was interesting. With that display in, the mill wouldn't power up at all. No lights, no spindle, nothing. That was pretty weird. So the next thing I tried was putting back in the original display that my mill had in it, and it worked. Everything worked. A little prologue here about these displays, because I figured some things out after this video was shot. So while these displays all look the same, if we take a look at the part numbers, you can see that some of them are marked 16p and some of them are marked 4p, and that's clearly pulses per revolution. So the pulse counting and conversion to RPM is being done by the display, not by the sensor. So apparently some of these machines have 1 hole in that disc and some of them have 4 holes, and that's why you have to match it up with the right display. So amazingly, having a bad display will also keep the mill from operating properly. Very strange. Celebration, and now we just have one last thing to fix, and that's the belt alignment. You can see that when it runs, it pops down a rib there on the pulley. So that means that my drive pulley is a little bit too low. Luckily, we can fix that in situ. We just have to remove the outer set screw, loosen the inner one, and then we can just go in there and pry that pulley up a little bit. And after a little bit of fiddling with that, you can see that it now runs perfectly. So that's progress. The next job was to modify the dust cover. Because I routed that wiring outside of the casting, the wiring needs some place to go. So I just marked this out, and we'll cut a notch in there for that. And it's a little hard to judge how deep this notch needs to be, because the wire is coming out at kind of a very gentle angle. So I just did trial and error. I just enlarged the notch over and over and test fit it until it fit. And then I went in and deburred it and made sure there was no sharp edges anywhere in there. And now we need some kind of like a grommet to protect the wiring from the sheet metal. 1/8" vacuum line for cars is great stuff to keep around for this. You can just slit it down the side, and you can make a grommet of any shape that you need. So we just slide it in there and trim it to length, and you can see how that's going to be very well protected indeed. And then when you're done, you just super glue it in place. And now that dust cover fits on there very nicely. Our wiring is protected, and job done. But we weren't quite out of the woods yet on the speed control issues. After using it for a while, I noticed that the numbers on the panel no longer matched up with the RPM. Originally, each of those numbers was roughly 100 RPM, which was really useful. But now the entire upper half of the knob's range was all maximum speed. So that was clearly due to the mismatched potentiometer issue. So I took the disco potentiometer that came with the newest kit and installed that guy, and we'll give it a shot. And that did the trick. The numbers once again line up with RPM. The knob that I like won't fit on this pot, so I'll just have to live with this Disco knob for a little while. And so now we can reassemble everything, and of course one of the panel screws from the PCB in the back disappeared into the chip tray, and I spent 20 minutes looking for that screw, and it is gone. But the last thing to do is replace the battery in the Coil DRO, which went dead in the middle of all this, to add a little bit of insult to injury. So we replaced that guy, and then set the units to weird, and we're off and running. So this was a pretty epic repair over the course of multiple weeks, but I want to give a shout out to Matt over at Precision Matthews. Yeah, he was overnighting me parts, and he was with me all the way, responding to my emails on Sundays. Like, really great support. So thank you, Matt. It's great to have my mill up and running, making chips again. So I hope you enjoyed watching this. Thank you very much for watching, and we'll see you next time.